Um, so the agenda, which we briefly talked about earlier, um, I'm gonna start with a little primer on generally how Eiffel event signing works, since it's probably not something that everyone is super familiar with, and then a little statement of discussion about the actual problem, and then I have outlined a number of different solutions that I have found. And again, it will probably take maybe 30 minutes. We'll see. So, first of all, why do we want to sign events? Well, they're usually published on a shared message bus, and there are usually multiple contributors to that bus. Um, some of the event times that are sent are, they're sensitive. It could be artifact location. It could be confidence level changes that in turn could trigger deployments or releases, etc. So it wouldn't be great if anyone could publish any kind of event to the bus. You could implement some access control on the message bus itself by having multiple exchanges in the RabbitMQ case, or um, if you're using some other broker, you could possibly introduce access control lists that would somehow control what kind of events different people would be able to send. But that won't really do either, since there are many different kinds of artifact or different sources. So regardless, you using the message type, or there are many different dimensions where you might want to introduce access control. So that's probably hard to do with an asynchronous message bus topology. However, if we sign the events cryptographically, we could authenticate the senders, and it would be up to every consumer that cares about who actually sent the events that they're processing. They would be able to verify those signatures, and then you can use any kind of granularity that you want. And of course, signing also makes sure that the integrity of the events is maintained. In other words, it's not corrupted, or either by mistake, or a bug, or maliciously. So it's actually a little bit surprising that signing of events hasn't been more of a thing. I mean, it's has very little ecosystem support, which I'll talk about in the next slide, because it really is a huge problem if you have a bus where anyone can publish anything, unless you by any other means lock it down. But even if you, I'm pretty sure that Ericsson has authentication enabled for RemRem publish, for example, but that only makes sure that it could be a large number of authorized senders of events, but it doesn't solve the problem, only mitigate it a little bit. So the current ecosystem landscape looks like this. We have support for signing in the .NET SDK, but the support is kind of weird, because the sending party, the publisher of the event, will generate a key on the fly and include it in the public key field in the event. So it certainly supports integrity checking, but not really authentication, since a new key is generated every time. So unless that the generated public key is distributed to the consumers in some other way dynamically, I don't see how it's useful in any way, really. So I don't know really what they were thinking in that case. The Go SDK has implemented support for signing and verification. It hasn't been pushed to GitHub yet. It's still on my laptop, but there's mostly documentation and tests remaining to be written. So we'll have full support for it in the Go SDK. And finally, the Eiffel Broadcaster Jenkins plugin, as of I think January, maybe even December, has support for signing events. Both sort of global events like activities being sent for build jobs, but also events sent by the jobs themselves, which then would typically use another signature than the global events that are owned by the plugin itself. So we haven't started using that ourselves quite yet. We haven't set up all the necessary keys, but at least the version of the plugin required for signing is running on our Jenkins controller right now. So that's the extent of the ecosystem support that I know of, unfortunately. So there's some work to be done there. So this is the general look of a signed event. Everything related to security and signing is under the meta security subkey. You have the author identity field, which is a distinguished name indicating, identifying the sender of the event. And typically you would use this to select which public key you would use for the verification. The integrity protection field contains a few different members. These ones are the ones that are mandatory. The alg indicates which algorithm was used for hashing, and also the key algorithm. So in this case, it's an ECDSA 256-bit SHA checksum. And the signature contains the base64 encoded signature of the whole payload. Now, so this part is conceptually very simple. What's a little bit annoying here is that we are signing, the signature is stored within the part of the JSON blob that's also signed. So how does that work? Let's have a little look. So it works by setting the signature field to an empty string, and then you sign that, and then you sort of patch the signature into the object. So you would set the author identity to whatever value you want. You set the algorithm. You make sure the signature is set to an empty string. It shouldn't be absent. It should be set to an empty string. Then you serialize the event to canonical JSON form. That's a sort of standard representation that's also used for JSON Web Tokens. And it basically just they've chosen a one single representation of JSON. So I mean, there is no white space between, except within strings, and there are some escaping rules that need to be followed and so on. So there is some support for generating canonical JSON in most languages. Anyway, serialize the canonical JSON form and compute a digest of the resulting string. In this case, we have chosen SHA-256, and we're also indicating this in the algorithm field. And then once you have that digest of the full payload, you sign that together with your private key. And then you're done with the signing. To verify a signature, you would do it the other way around. You would save the signature from the signature field, clear the signature field, set it to an empty string, serialize it to canonical JSON form, compute the digest, and use that digest together with the public key to verify the signature that we saved. Oh, there's actually, yeah, the verification also needs the signature, of course. Yeah, my pseudocode has a bug. So it's not, nothing advanced really. However, what public key should we use on the consumer side to verify the signature of an event? Usually an ecosystem within a company or an organization would have multiple different senders, and they could potentially have different access levels, or they would send different kinds of events, and we would one sender could be trusted for a particular kind of event, but not for another kind of event. Any questions so far? Is everyone on board?
Yep.
Okay, good. So this ties back to the feature in the .NET SDK where they stored the public key, or the public half of the key that they used for the signing is stored in this field, the meta security integrity protection public key. I'm not sure really why this was added, because again, it doesn't add any security. It only allows you to detect corruption, malicious or non-malicious corruption of the event. Well, you can use it to authenticate the sender, of course. So I'm not sure how it's supposed to be used. The only thing that I could figure out was that if a new publisher could somehow like send a bootstrap event with the key that they will use going forward, a consumer could use that. If it's a new sender with using a new key, they could save that key for later, and as long as the sender would keep using the same key, they could make use the save one for verifying the events. But of course, I mean, how would you know if the very first, if the bootstrap event is legit and signed by the correct party? Not sure how that could be done really. So I don't know how this would actually be useful, except as maybe some kind of convenience. I mean, sure, it's convenient that the key is right there in the event, but you have to make sure that it's the right key anyway. So I don't know. The documentation doesn't say very much about it. And this is one of the most interesting options, I think. And that's similar to the existing public key field. We would introduce a new meta security field, or I guess meta security integrity protection probably, that would contain a certificate. Same kind of certificate you would use for a TLS communication, for example. The point of this exercise would be to allow that certificate to be signed by a certificate authority that will be known by the consumer, known and trusted by the consumer. That way, senders could be, you would only have to configure consumers with a key for the certificate authority, and then they would be able to trust any certificate. No, sorry, any key. No, sorry, no, any certificate issued by that certificate authority. So that would mean that you would have very limited configuration on the clients. And because we have the author identity field in the event payload, we should be able to use that to authenticate and authorize the event, right? Because the subject in the certificate would then match the author identity. In other words, the certificate authority issues the certificate for a particular author identity. So that's how we know that anyone who presents a valid certificate signed by the CA, we also know who that person is, or who that service, the identity of the sender, simply put. So this would I think in many ways be pretty attractive, assuming that you could. I mean, it does require that you have certificate authority infrastructure within the organization. So there's a fair amount of overhead for that. But if you're okay with that, I think this would be great. Unfortunately, we don't have such a field for the certificate, so we would have to make a change in that would affect all events. which isn't a huge problem, but it's maybe the biggest problem is that we don't have it right now. It would take a little while to add that. It would also make the events significantly larger. Um, just a signature isn't very large, but I think a certificate weighs in at about a kilobyte or so. And that's, I think, for the binary DER encoded certificate. If you use base64 encoding, I'm guessing it's going to be about 35% larger. So, 1,500 bytes to every signed event on top of the author identity and all that, and the signature itself. So that could at least be a drawback, because it basically means that the size of most events will become twice as large. Another option, which is the very simplest one, is to have each consumer configured with a list that maps event sender distinguished names to their public keys that they have ever used. This one is super simple to implement, but it also, if you have an organization where you have one or more dozen senders and one or more dozen consumers, and you want to start using a new public key for an existing sender, or you're introducing a new sender altogether, there will be lots of configurations to update. So it's simple to set up, but pretty expensive to maintain. A version of that is to have this configuration shared among many consumers. So it's basically the same kind of data structure, except that you would maybe store these mappings in a file in a Git repository that everyone can pick up. You could use a web service or some kind of other API to perform this lookup. Assuming you can get the shared configuration safely, and that you can always trust the data in it, then this should be a pretty attractive option. In the first case with the Git, of course, it means that anyone who controls the Git will effectively control all the keys and could do lots of funny business. So it isn't the same kind of zero trust model that you would have in the previous example, where it was up to every consumer to explicitly list which public keys to allow. One thing I could mention is that regardless of what option you choose here, you would most likely need to define some kind of access control list that configures which senders are allowed to publish what kind of information, so that you don't have a case where someone malicious who does sign its events sends an event that is not really authorized to send, like a release decision or an artifact location, something like that. So you still have to have local configuration for each service, really, where they indicate that for this kind of event, I only trust it if it comes from this particular set of senders. And finally, the solution that's possibly the best one, but is also the most complicated one by far, and that would be to use the tools in the SIG store toolbox. They are primarily aiming for sort of real artifacts, OCI images or something similar. But they have a bunch of different services, at least some of which are public and available for use by anyone. So with SIGSTOR, you have a certificate authority that can issue certificates, short-lived, only like 10 minutes. So you would have to request quite a few certificates. Um, all the certificates and metadata about them is sent to another service. Same thing with actually the details of the signing itself. So the Recor transparency log will contain information about all the signing operations that ever take place. And the consumer would then be able to talk to Recor to obtain the signature that was used in a particular point in time. Again, with the short-lived certificates, at least by default, 10 minutes, but maybe it's configurable. So you have to. The question of what certificate is valid for a particular sender depends very much on when the point in time that you're interested in. So I think this should work fine for Eiffel events too. The tool that does the signing doesn't necessarily have to sign OCI images. It could sign any data blob, potentially in memory. So it should work fine. However, the authentication of the sender to be able to obtain this from the certificate authority in order to obtain the certificate is done with OpenID Connect. And it's not immediately clear to me how that would work in a machine-to-machine context. Sure, if you are building artifacts on GitHub with your account, I imagine that it would be sort of more natural to obtain an OpenID token for that. But in the more general case of publishing events, I'm not sure how that would actually work. And it seems that the OpenID Connect part of this is sort of integral to the solution. So I think it would be hard to change it. But apart from the general complexity and whether it's not clear how the authentication is going to work, I think this one is quite good. The transparency log contains both the artifacts and what was signed using each signature. So I mean, other questions that could be tricky to solve for the other cases we talked about. What happens if you need to roll a new key, for example? How do you deal with that? This automatically takes care of those questions. But then instead you have other questions surrounding, for example, authentication that are not entirely obvious. Right, so that was actually the slides I had. So I can add a few comments myself. So I think we're going to start with really the simplest option so far. I guess it's no. Yeah, so this one. That's what we're going to do when we shortly introduce signing of events coming from Eiffel Broadcaster. And yeah, so actually, yeah, to start off, it's only going to be Eiffel Broadcaster, and we have various Go services that would be interested in verifying the signatures. So the simplest solution definitely has limitations, but that's where we're going to start. Adding the certificate authority is, again, I think quite attractive, but it would require a protocol change, and it would make the events probably twice as large on average, if not more. We've also considered extracting the configuration to shared files that are, for example, shared through a Git repository. But we'll see if we ever do that. All right. Any comments or opinions or ideas?
Thank you very much for the introduction. Himesh, please go ahead.
Yeah, I had a question about this certificate. So, for example, what happens if we need to update a certificate and like because we will the password or the certificate will be valid for a particular time range, right? So, how is it actually handled and how is it
Yeah,
done?
that's interesting. I mean, the certificate will have a validity time. Um, and that's true both in this case and in the SIG store case. SIG store is, again, it's just 10 minutes validity, but you can
Yeah.
still, you would have to, uh, I mean, if you do the verification immediately when you receive um, the event, then, the certificate would have to be valid. Otherwise, it's going to be strange. Um, but you also have the case where, and if you roll a new certificate, you would just start using the new certificate. But when doing the verification of especially old events, you would have to look at when was this event sent and was the certificate valid at that time. Um, so we don't have senders. Let's say a sender, a malicious sender has obtained a certificate and they have issued a new certificate. Um, but actually, no, that doesn't make any difference. But yeah, we would have to. I didn't write that here, but we would have to have support for some kind of certificate revocation method, either OCSP or a certificate revocation list. Well, that would be necessary for dealing with um, certificates that they might still be valid, but they aren't. I mean, they're in the validity dates set up for the certificate, but maybe they have been compromised. Um, so that's really true for any kind of certificate-based solution. And if certificates aren't used, then we don't have such a mechanism. We would have to, if we, for example, look at no this one, and a particular key has been compromised, then every consumer would have to update themselves, just like if it's a new key, for example. So that's a limitation. That's actually speaks for certificates. I mean, if you use OCSP, which I think it's the online certificate uh, something protocol, which allows you to look up whether a certificate is still valid. Uh, I I don't know OCSP sufficiently well to be able to tell if it will be usable in this particular case. But assuming it is, that's something we would want to support. And it only supports certificates, not if you just have the keys. That was a long-winded answer. I don't know if it answers the question, but
Yeah. It did answer the question. Yeah, yeah. And also like another thing is when we have like I mean one of the things that I was thinking is we might have like these consumers or the events coming up, and will the events be blocked? I mean, if we don't have an authentication or something, will these, of course, the events won't work, but will they be stored somewhere or will they be completely vanished?
I mean that would be up to how you set things up. Um, by default, if senders are allowed to publish directly to the shared message bus from which people consume directly, then there is no possibility to like filter out events that either aren't signed at all or events that are signed with um, an expired key or expired certificate, for example. But you could set up a topology where everyone publishes to like a holding area, and then you have a service that pulls events from the holding area, verifies the signature, maybe validates the events. I don't know, you know, whatever you feel you need to do. and then publish it to another exchange that in turn people can subscribe to. That could be an option. Then you would be able to make sure that every single event that you consume in the end, every single event that ends up in an event repository that you can search for, all those events maybe have been signed and the signature checked out. So that could definitely be an option.
Yep. Thank you. Thank you.
So, Magnus, did you see the question from Tobias in the chat?
Ah, right. When a certificate or key is revoked, then we can no longer trust any of the old events that we can find in the event repository. I mean, in that case, we would. I mean, usually certificates, I guess, are revoked if their private key is, or if for some reason has been deemed compromised. So I mean, wouldn't it be up to, if it depends on why it's being revoked, I suppose. If we know for a fact that, you know, the key to this certificate was compromised at a particular point in time, then we could trust that all events prior to that time are still valid. But if it was compromised and we don't know when it was put to use, I mean, when did potentially malicious events start to be sent, then potentially we mean that a whole lot of old events would be hard to trust. So I suppose it depends.
But then, for example, in this case, or maybe also in the certificate case, then each of the consumers would need to have a list of like revoked certificates, or maybe that's handled by the protocol. But basically, you know, if you want to go backward in time and look at old events, then you need to have track of, okay, which certificates can I trust and not trust, and when.
Yes, yeah, you would have to do that. Yep. So that quickly gets complicated. I don't know to what extent either a certificate revocation list or OCSP, to what extent they help out with, you know, historical things. Because you need to know probably then when was a certificate revoked. Maybe you have a rule of thumb that if we think that everything up until the revocation time we think is okay, for example. But if OCSP doesn't provide the revocation time, then it's going to be hard. And yeah.
But I guess this is not something unique for us, but there could be the same problem out there. I mean, with those certificates that are, I mean, if you need to sign artifacts that are stored and then revoke certificates, and how do you trust them and so on?
Yeah. I mean, it's definitely not unique to Eiffel. Absolutely not. No, that's true. I mean, I suppose if, I mean, if you have artifacts signed with an expired certificate or a revoked certificate, I should say, you could always re-sign those binaries, for example, if you have a fresh key. That would be an option, but we never touch old events. So I think maybe that's a difference between our use case and like the rest of the world.
Okay, yeah.
Tobias had another question here. Does this not also become a problem when a certificate validity period expires and it not explicitly revoked? I mean, isn't that a simpler case? Because you would have to inspect the validity period of the certificate and not accept, you know, make sure that an event sent within that time frame uses, yeah. See that Tobias is typing, so let's wait for his question.
But at least it's an interesting area. So how much do you think you have a problem, or if we look inside our use cases that we most use Eiffel for is inside our companies, is this going to be a big issue, do you see, for example? Or
I don't think so. Really, but I think if we're going to go into further into this territory, we probably have to talk to people who really understand this and who know enough about certificate revocation list and OCSP to be able to help us judge whether those options are good.
A question about this one they have up here that you think they're starting with. I guess that if you have a list of senders and public keys, you could run into kind of like the same problem. I mean, if somebody, managed to delete their private key or forgets the password or something and needs to do a new public key, then you need to push a lot of updates to the consumers.
Yep. I mean, it's same thing if we get a new sender or an old sender that for whatever reason needs to be using another key. Could be a matter of they want to use multiple keys concurrently just because they want to reduce the risk of compromising the single key for everything, for example. Of course, you could argue in that case that they should use different sender DNs. That's probably possible. But I mean, we're going to see lots of new keys, definitely. And that's the drawback of this solution. It's very simple, but you have to really maintain that list of keys.
So when it comes to this with why we have a public key, I don't know in the protocol why we have it there, but one thought is the reason is there to be able to cater for knowing, okay, this old event, what key was used to sign. So you, of course, then the client has to validate that the public key is real, but it's more or less, okay, which key was used to sign this event? Because if you switch keys, you might have a problem.
Yeah. That's definitely that could be the case. Yes, that you, if you have multiple public keys for a single sender, then including the public key in the event would at least allow you to not try all the public keys until you get a match. Which one to use. Yeah, that's true. Whether it's worth it to include the public key in the event, that's another story. It's not that expensive to just try all the keys in order. Or of course, depending on how many keys you have for a particular sender. I mean, if you have 1,000 keys, then it's going to be expensive. So Tobias writes, could it be valid to revoke events from the event repository should the key or certificate be compromised and revoked? That is, remove the events that were signed with that key certificate from the event repository. Historical events and links to historical events would become a problem in that case. Yep, definitely. I would probably prefer if clients are aware of the possibility. I don't know, because if you delete events, you will break whole chains, and there could be cases where two events, but of course, two events are connected via an intermediary event, and if we just remove it, then they would be disconnected. On the other hand, if the intermediary event, or the event in the middle has been compromised, then we can't trust anything anyway. So I don't know. But if you have the whole revocation handling in the consumer, or whoever's searching the event repository, they would be able to at least make some kind of informed judgment. But if the event is just gone, then you don't know if it was ever valid, or if it maybe was removed.
Another question popped up when it comes to this. So do you have any idea of OTel, Open Telemetry? Do they have any of this validation at all, or?
No, I don't believe they have. I haven't seen anything about it.
Okay, so that's pure, you need to trust the service and the channels and so on.
Yeah, I think so.
Hmm.
But it's an interesting question. I mean, what happens if you could have services that contribute to the set of traces, globally, and have no way of yeah, that's interesting.
Yet another question for me. When it comes, you said about the ecosystem support, have you seen or heard anything about outside? I mean, events, or this is not only Eiffel that has it, but other event protocols and so on, signing
I
and
haven't
such.
looked at that much explicitly for it, but I'm pretty sure. I don't think Seed Events has it, for example.
No, if not, I wonder how it is with cloud events. I don't remember on top of my head right now.
Yeah, I meant cloud events, not Seed Events. Maybe the situation is different, since you typically use webhook to send. They should have the same problem, I think.
Yeah.
Unless you authenticate on the webhook side, so you only provide your credential. Yeah, I'm not sure. Tobias has another question or comment, I see. If an event, for example, the composition defined event, links to a bunch of artifact created events where my consumer trusts the publisher of the CD, but does not trust the publisher of the RC, or the RC was not signed at all, what would be the proper way forward for my consumer in that case? Should my consumer always verify the signature of all links before making any decisions? All excellent questions here. I mean, in many cases, I would imagine that if you trust the composition defined and the publisher of that event, I would at least trust an event that isn't signed. Well, it depends on the context, but and the party sending the composition defined. I mean, is it any service, or is it reputable service where the risk of artifacts or compromised artifacts or malicious one ending up in the composition? What is that risk? So I think you have to have a, it's not a binary choice. There are nuances.
Well, Tobias is typing. I did a short Google. Yeah, we take Tobias first.
If the RC publisher's certificate or key is revoked, should all publishers that have events linked to that RC also have their certificate or key revoked? I would say no. Why would? Yeah, I'm not sure at all. If I have linked from my CD to an RC that has been signed by a compromised key. No, that's definitely true. If artifacts that go into a composition, and if they have a compromised key, trusting the composition to find is perhaps something you shouldn't do. No, that's true. Thinking what the consequences would be of that.
How is it in artifact cases? If I sign an artifact that has that contains some like libraries, you never validate the other libraries, but you trust the signer to have, know what they're doing, right?
Mm-hmm.
Or would you basically take a look at the SBOM and go down the whole SBOM chain and validate all the signatures of all the artifacts?
Yeah, maybe. Yeah, some all very good questions that I haven't thought too much about.
I'm sharing in the chat also. This is what cloud events say about it. And when it comes to security, they basically said that the protocol level security should be employed to ensure trusted and secure exchange of seed events. So they don't really give you any hint, but I guess they just said that it's the protocol level, basically like a MQP and so on, that should deal with this. That's their kind of solution to it.
Yep. Yeah, and if you use webhooks, you would use any kind of HTTP-based authentication. So I mean that's one way of doing it. I think it's way easier in most cases, but it's also more limited.
And then when we're dealing with this, they also have another comment about data, but they recommend that it should be encrypted to entrust. The mechanism for such encryption is also the specification. And I don't think we've actually talked anything about, or in Eiffel, I would say the principle is openness. So you shouldn't include information inside the Eiffel event which can't be distributed.
No, that's true. That's true. I mean, that's one of the reasons why the source change events, for example, don't contain the commit message. Actually managed to use up almost an hour.
Yeah.
Any final questions or comments? I mean, I don't know if we should think about the one concrete proposal that was made is this one, whether it makes sense to add the ability to specify a certificate that was used by the signing. It would definitely solve or avoid having to, it would of course be optional, but it would be there if you wanted to have CA-based authentication.
I mean, it's an interesting idea, and maybe we should at least discuss it. And then also a question of how should we log such a discussion? Should we like write the issue on this to add it? And then in the issue, we can discuss it. And if we decide no, then we will log it in the issue and have that as a reference in future discussions.
Yep. Yeah, that's a good idea. Oh, we haven't taken any notes now, have we?
No.
Mm-hmm.
So
I think we can follow
uh,
up regarding the addition of the field here, or as protocol maintainers, and sort of let the thought marinate for a while, and we'll see if we'll adopt it.
So I will need to leave for another meeting I have now. And do you want the recording on, or should I stop it when I leave?
I think we can. I suspect, this weird thing's going to happen to the meeting if we continue, even if you leave. So I didn't expect it to go on for this long, but it's. I think we have a good discussion, and we'll see if we'll maybe do a follow up later on. And good. Thank you all. Take care.